So if you take a look at your variable list, you can see that we already have these two equations figured out. All right, I'm going to write those a little bit bigger right next to this, and I'm going to just write them in a generic way. V equals V naught plus AT. We say naught here. This is to mean the initial condition of a variable. We can say V naught, which would mean at time equals 0. That's what that's going to be. But there are other variables that might, maybe something like F naught would be the force at mass equals 0. Something like that. So naught just means our initial condition. And you'll see that pretty frequently. So then we've got x equals x naught plus v naught t plus 1/2 at squared. Now you might notice the x on these velocities here. And that's because we can actually do this in multiple dimensions. If I wanted to do this horizontally, I'm looking at x. If I wanted to do this vertically, well, I could just rewrite this equation to say y equals y naught plus v naught t plus 1/2 at squared. And there might be uses for writing it this way. But for now, we're just going to worry about using these equations to solve one-step problems. And so let's say we have something nice and simple. We've got a car driving along with an initial velocity, so v naught of 15 meters per second. We're going to say that car accelerates at 2.5 meters per second squared. I'm going to say it does that for 20 seconds. I want to know how far does that car travel in that 20 seconds. So the way I always set these up, and the way that you should set these up, is by making a variable list. We have certain variables that we're going to be using in all of these kinematic equations. And when we get to multi-step problems, we're going to need to be able to look at those variable lists at different moments in time and see what we have and what we don't. So for now, we're just going to make a straight variable list. I would start with x. X naught, v naught, v, a, and t. And so right off the bat, what can I list out here? Well, v naught is 15 meters per second. I know that. I've got that right there. So 15 meters per second. I know my acceleration is 2.5. And I know that that's going to happen for 20 seconds. Now, what about these other variables? What am I looking for? Well, I'm asked to find how far does this car travel during that time. So what I'm really wondering is, if I'm starting at this position, this is my x naught, I want to know how far away is x as compared to x naught. What I'm really asking is, what's the change in x? So if I'm asking what's the change in x, well, it stands to reason. My starting point is my 0 point. We call this a frame of reference. So in physics, we're often going to need to think of a frame of reference. We're going to need to decide this for ourselves. You could say that this x naught, you could say this starts at 55 meters if you wanted to. And then you would just need to be able to account for this x being an additional 55 meters ahead of the change in x. The easiest frame of reference, though, the easiest thing we could set x naught to is going to be 0. In most cases, that will be true. So we're going to say x naught is 0. Whenever we're dealing with a frame of reference here, we use what's called an inertial frame of reference. What that means is the thing that's doing the moving, or the thing that's being referenced against, the thing that's standing still, in this case it would be the road, is not accelerating itself. It could be moving, we'll get more into that later, but it should not be accelerating. And the road, clearly, the road is not moving relative to the car, it's fine. The car is the thing moving, the road is standing still. So this is a solid reference point. So we have all of these variables, we're looking for x, and now we can go, what equation do I use to solve this? Well, if I look at this one right here, this guy, it's got the x that I want to find in that equation, and I have every other variable to find it. So I can go ahead and set this up. I've got x equals x naught plus v naught t plus 1/2 AT squared. First off, x naught is 0. I can cancel that out right away. Then I've got v naught t. That's going to be 15 times 20. Then plus 1/2 of a, 1/2 times 2.5 times 20 squared. And then we can just plug that into a calculator and see what we get. And if you plug this in with me, you should get 800 meters. So our x is 800 meters. Fantastic. Now, that should make sense. One more thing we can do to check this is my final measurement is in meters. I'm using meters per second, my velocity, that's meters per second, times a time, which is in seconds, plus, I'm going to not worry about the constant there, the acceleration is meters per second squared, times seconds squared. So this cancels out, and I'm left on both sides of my equation with meters. So that kind of confirms the accuracy of this equation. So let's do another one. Let's use this same situation, but this time, let's find my final velocity. I want to know what's my velocity at the end of this 20 seconds. Well, to do that, I'm going to go, what am I looking for? Velocity. What equation has final velocity in it? Well, this one does. And so I'm going to need to use this equation. So I'm going to set that up. Velocity equals v naught plus at. And so I'm going to plug my variables in. I've got 15 plus 2.5 times 20. And I end up with 65. So my final velocity is 65 meters per second. Great. Let's try a similar problem, but let's do something a little bit different. This time, let's have the car accelerating at 2.5 meters per second squared, but let's say it's going to travel a certain distance. Let's say it's going to travel all the way to 200 meters, and it's going to start from 0 meters per second. Now I want to know, how long does it take to travel that 200 meters? So let's set that up. We start with our v naught is 0 meters per second. Our acceleration is 2.5. Notice I'm using the same variable list. If this was a new problem, if I didn't have this handy-dandy computer set up, I would rewrite my equation list, my variable list. And then I've got a final displacement of 200 meters. Now that's going to be 200 meters ahead of x naught. So if I said x naught is 50, well then this would be 250. It all depends on how I set that frame of reference. So a little bit of freedom in that, and we will play with that later. But for now, x naught is 0, x is 200. And I'm wondering, how long does that take? Well, I'm looking for time. And so I'm able to use one of these two equations to find that time. But I don't have the final velocity, so there's no way for me to solve this equation. I am missing a key variable. However, in this equation, I have x, I have x naught, I have v naught, and I have a. So I have everything I need in order to solve that. So let's do that. I've got x equals x naught plus v naught t plus 1/2 at squared. Now, x naught is 0. Cancel that right out. And v naught is 0, so I cancel that right out. That's the first thing I should do once I set up these problems, is I should find my zeros, get rid of them. And then I can start plugging things in. So 200 is my x, equals 1/2 at squared. Well, I have a, so let's put that in right away. It's 2.5. So now, 1/2 of 2.5 is going to be 1.25. So I've got 200 equals 1.25 t squared. So I can divide both sides by 1.25. That gets me 160. 160 equals t squared. And now I get rid of that square by taking the square root of both sides. And that will give me 12.6 equals t. So time equals 12.6 seconds. And now if I wanted to, I could figure out the final velocity of this car. I could take 12.6 times my 2.5. That would give me 31.5. So that is the gist of how we solve these single-step problems. So go ahead and practice some on your own. All you're going to be doing is looking at your problems and identifying which variables do you have. You're going to be looking for meters per second for velocity, meters per second squared for an acceleration. You're going to be looking for meters for displacement. And then finally, seconds for time. Once you find those variables, make a variable list, list out your equations, and decide which one is going to be best. Then plug your numbers in, get rid of your zeros, and solve for your solution.